Assalamu alaikum and welcome to KS Academy, and today we are solving a truss element using ABAQUS. The horizontal member of truss element is 1000 mm while the vertical member of truss element is 750 mm. The elastic modulus is 200 GPa and the cross-sectional area is 645 mm square. We need to calculate reaction forces, calculate stresses and deformation. Now we open a ABAQUS file. Here you can see a lot of options available: property, assembly, step, interaction, load, mesh, optimization, job, visualization, sketch, etc. First we create our part here. You can see here create part. After clicking on create part, this type of window will be appear. We change a name of part 1 to truss. Modeling space 2D planar, type deformable, base feature wire, and approximately size convert to 2000. It's depend on you. Continue. After clicking on continue, this type of window will be appear. You can see here a lot of options. This is for point, connected line, circle, rectangle, ellipse, fillet, trim option. A lot of options are available here. We are creating our truss element by using line element. Our first coordinate is 0, 0. Our second coordinate of truss element is 1000 mm and 0. Our third coordinate of truss element is 1000 and 750 mm. This element is directly connected to node 1. After drawing this, we draw our fourth element by using coordinate. Click on this and then give 0 and 750. The truss element will be drawn. Now you can give a dimension by using this tool. Click on this point and this point. The dimension of this is 1000 mm. Click on this point and this point. The dimension of this element is 750 mm. After drawing on this, click on this option and done. The truss element will be drawn. Our part option is finished here. Now we continue. Our next part is property. Here you can see create material. Our material is truss steel. We give only here you can see general content density, a lot of option, mechanical content, plasticity, damage for ductile material, etc. We analyze our truss by using a elastic linear elastic. You can see here elasticity. Click on elastic. Here you can see Young modulus and Poisson ratio. Our model Young modulus is 200 GPa and the Poisson ratio of steel is 0.3. And the Young modulus is 200 GPa. We convert this to MPa. Sorry. After clicking on this, OK. Now we give a next part, create a section. Here you can see we create a section beam, and here clicking on truss. After clicking on truss, we give a cross section area. The cross section area of our model is 645 mm. This truss still they automatically select from here. After clicking on OK, now we select all the truss elements. Click on done. Section 1 we create 645 mm cross section area. After clicking on OK, the section is assigned to this model. How you can see our model is assigned a cross sectional area. Here you come view option. Here you can see part display option. give a render beam profile. After clicking on this, apply the beam is rendering. You can see this is the diameter of each truss element bar. Now we remove our from here. Click on this box. The render beam profile option will be disappear. After clicking on property is assigned, now we create assembly of this. Here you can see create instance. After clicking on create instance, directly apply OK. The part assembly will be created automatically. Now we give a step option. Here you can see create a step option. After clicking on create, we analyze a static journal. Here is a lot of option available: couple temperature displacement, couple thermal electric, direct cyclic, dynamic implicit, explicit, geostatic, heat transfer, mass diffusion, soils, statics, rex, visco, etc. Here you can see general option: linear perturbation, buckling, frequency, static linear, steady state, dynamic direct, substructure generation, etc. are available in this option. Now we create our model. Here is static general. After clicking on this option is available for geometric non-linear. Our truss element is analysis and linear analysis. Now we off this and click on OK option. Now we give interaction. There is no interaction with another object. Interaction is used for connecting with another object. Load, etc. C or a P bar are used. We connect this by interaction, embedded bar, etc. Now we apply a load. Here you can see the load option. We create a new option, concentric force. After clicking on this concentric force, here you can see the nodes will be paired. We apply our force on 3 and 2. Our 3 is vertical force is, click on this, continue, click on node, done. Here you can see our force is 110 kilonewton downward direction. CF1 is for horizontal and CF2 is for vertical. Here you 110 kilonewton multiply 1000 and apply OK. Here you can see the load will be applied on node 3. Similarly, the load create a new force apply on node 2. Here is the horizontal force is 90 kilonewton. We multiply with 1090,000. Click on OK. This is in positive direction. Here we cannot give a negative sign. After assigning a load portion, here we give a support condition. This is hinge support. On node 4 is also hinge support. On 2 is a roller support. First we apply a roller support here. After clicking on this, create new displacement rotation. Clicking on this, continue. Click on this node, done. Here you can see the vertical force is 0. So we give a u2 is equal to 0 and allow u1 and u3 direction. Okay. And the next we create a hinge support for this 4 point and 1 node. We continue, click on this, hold shift and then click. Click on this node and hold on shift and click on this node. Done. Hint support x direction and u2 direction is 0. Now we can click sorry